contest rules say that contestants will circuit bend an existing device to create a unique musical instrument that can be easily recreated by others while following these guidelines. The device you bend must be battery powered with a power no greater than 9 volts. The project must be completed for a total cost of $70 or less, and this includes the device you bend and all the parts used to bend it. You'll need to create a bill of materials, build instructions, and photos sequencing the build step by step. I use components that are readily available. So in this circuit, for this one, you can buy the pieces from Walmart and Home Depot as an example, and still be within the budget. If you use alternative sources, or you have some actually old devices are lying around which you've not otherwise using, you can actually make 2 devices that for less than the budget. For me, there's no difference between software and hardware. As an example, recently Moog introduced the Mini Moog Model D iOS app for iPads, iPhones, etc. And a couple of years ago they reintroduced the Mini Moog Model D using the original plans. Likewise, there's both you can buy a Model 15 modular synthesizer, and you can also buy a Model 15 iOS application. For this project I used several tools to cut and drill wood and other materials. Here I have safety glasses. When you're drilling, always put a piece of scrap material underneath the object so that when the drill goes through, it doesn't ruin your table surface. And you want to be very careful that you're cutting away from yourself, and so if you slipped or something, you don't take the edge of finger off. Some tools such as glue guns and soldering irons obviously get very hot, and if used used correctly, can also lead to burns and potentially fire hazards. Paints and glues should be used in a well-aired space. So this year's circuit bend basically is what I wanted to make last year. So last year I was going to do this guitar type device, and I started with various designs and was starting to very severely over-engineer it, should we say. So the idea with this one was basically you have the phone at one end, keyboard down the other, and then this point and somewhere in here would have been the guitar strap mounts, but the problem is that this is actually very light and the balance point's in the wrong place, so that it wouldn't balance properly if I put the strap where I wanted the strap, and it would take me a long time to get this cut out, so sort of over-engineered, and basically I ran out of time. Depending on what you use, you can actually make 2 of these for $70. Let's go through the features of this year's circuit bend. The body this time is made with, this is a shelf. I purchased melamine, is it? That's a shelf. So the guitar will sort of hang at your waist nicely, because guitars are actually not that light sometimes, so it does hang nicely. So I have say the piece of doweling, which is 1-inch dowel, and with these two pieces of scrap either side, the dowel fits between them nicely. They hold it in place, stop from going up and down. And then, because I've got a hole through the piece of doweling in the middle, and I put this peg here. I can basically put the doweling so that it's one end's here, one end's down the bottom here and the other end up, and I'll switch it around. And I cut a flat in the piece of doweling and glued on this piece of wood at both sides to attach the keyboard and mouse to. So that's the height is adjusted so that the piece of wood here lies flat on these pieces here. And originally I was just going to use a rubber band to hold it in place, but I found that wasn't good enough with just a band here. And then I tried putting magnets down the length of the dowel and on the body, and that worked okay, but again it still wasn't very secure. So eventually, because I had a spare cup hook less, I put a cup hook here and added a little bit of extra doweling on the end of each end, which I can just poke in the cup hook, and that holds it nicely, stops it from falling. And then a simple, much smaller rubber band has to be hooked over. It keeps it in place enough to be used. So it's very easy to unhook the rubber band, flip the unit around, and put the band back. So there you go. So it really now meets the design aesthetic that I wanted, which was one of those Easy Top's video, I think it's called Legs, where at one point the guitarist spins his guitar around. I thought that was very cute, and this sort of allows me to spin around the unit. So in this mode, this works like a guitar, you can strum it, and in the other mode, this is now a synthesizer sound, and this was an XY pad, so you can assign to the synth parameters to it. So that was the basic design, and it's worked really well. The pieces that turned out to be I had to do was the speaker on the back of the phone needed a I needed to cut a notch out so that the speaker could be heard on that side, and the battery compartment and the on-off switch of this particular USB keyboard, I had to cut a notches for those so I could turn the keyboard on and off and change the battery. Obviously the phone charging port and headphone port are here. Of course the phone can be used in Bluetooth mode, so you don't have to worry about wires, so you can use it with a Bluetooth speaker, or you can plug in headphones, or you can just use the sound coming out of the phone speaker. So I think it's really simple design to put together. Doesn't take long, doesn't take a lot of skill. So hopefully people really enjoy this design. Now the other thing about this design is, yes, it's basically, even if you buy everything brand new, you can make one for still less than $70. So you can buy the phone if you don't have a spare one or an old one lying around. If you want to use your existing phone, you can just use a couple of rubber bands to hold it in place rather than super gluing it, rather than hot gluing it onto the piece of wood. Having this notch at the end helps keep the bands in the right place. So one of the problems with a phone, obviously, is that if you swipe down from the top edge, it shows the notification area type of thing. So the problem there is that you don't want to do that while you're strumming. So I found this piece of old CD case I had lying around. And this seems to be thick enough to insulate the screen. So what I will do is I'll see if I can cut some strips and run it across the top and bottom edges so that it doesn't swipe down. The Bluetooth keyboard, you can pick them up for as little as $10 or less on Amazon now, and you can go into Walmart. I picked this one up at a Walmart for $20. So it's really is well worth making one of these just because it's so much fun. Guitar. So I have a keyboard. So you can do various things with that. And then I use the phone here, which also generates the sound, with I have 4 different synthesizer parameters. So I have VCF mod depth, pitch bend, LFO frequency, and LFO oscillator mod. So change. So the controls here are relative for depth, but it resets on when released. Likewise, the pitch bend resets on release. So this control, both the controllers I've used I've set to reset on release, and on this one the LFO frequency bend resets on the release, but the LFO frequencies are cumulative. So on the keyboard I had to glue down these 2 keys, because if you press those keys, glue so they can't be pressed down, these 2 keys, because they would change the display on the phone, which would again ruin the thing. So the same thing here, I glued these so they can't be pressed. That would change the software. So I have I could change the wave shape. Oops. Change square, triangle, and saw. I also have a distortion drive type shape. So I've got 3 different drive shapes. There's a linear, then 2 with fairly nasty curves. So I'm changing the drive shape. And of course some square wave doesn't get modified as much as at all, basically. So we've got quite a decent range of effects and different sounds. So, the main feature of this device is I can undo this rubber band and lift off the keyboard, turn it around, and put it back again. Oops. Hook the band back up, rubber band back up again. Now it's in, instead of being in guitar mode, it's now in guitar mode when I switch. So I can basically, with the guitar mode, you strum this section, and those XY controllers are now here. And then the fingerboard over here now provides chords. This is minor chords. Sorry, these are major chords. Minor chords. Oops, minor Yes, this one does flash when you're not using it. That's just it does change colour anyway you put your finger. You can see that. So sort of starts off. Oops, rotate the keyboard. So it has mostly red. It goes sort of to white, and then sort of up. I need to change the colour slightly. You can see it changing colour. That's just a simple sort of just visual indicator. I'm happy to put a lot more effort into the light show type things. So it just highlights the active strings. So, great fun. It's basically what I wanted to make last year, but over-engineered and gave up and made the workstat instead. And this is a modified version of that same sound engine. So I'm very pleased with it. So what I'm going to try to do is describe how the software works. So looking at the code, some people might think about it as one of these Moog workstats, whilst other people might even be able to imagine it looking like this with a lot more detail. So what I'm going to try and do here is describe how the software works. So the first part is the start of the file. The start of the file is basically boilerplate HTML. HTML is the language that the web page is written in. So this is the start of the synthesizer object. What this implements is a very simple subtractive style synthesizer. VCO, LFO, filter. This software was written to be used, or can be used, with web MIDI. So internally it sends MIDI messages between the components to make the changes. So when you press a key or you get a note on event, it generates a note on event object, sends it to the synthesizer, which turns the note on. If it gets a note off object, it turns the note off. If it gets a filter cutoff control change message, it will change the filter cutoff, etc. So what this synthesizer object is it's a set of software components. These are defined using the web audio standard. I have I create an oscillator, a wave shaper. I create some gain nodes, which are like variable voltage control amplifiers, and a filter. I then use the connect function to basically wire the components together to form the synthesizer. I also initialize some of the values of the different components so that they either usually quiet or have a sensible initial value. So this is the main piece of code that handles the input to the synthesizer module. It decodes the MIDI data . This part of the code is where I'm decoding some of the control change messages. So this piece of code is where I define names for the various MIDI message values. This makes it much easier to use later. The software is basically divided into two components. One part is the graphical interface, or the user interface, and the other part is the sound engine. I've already shown you how the synthesizer is basically put together as a set of web audio components, and there are many different attributes that can be changed. The user interface is the piece you interact with, so it handles the keyboard input, mouse input, and because we're using phones and tablets, touch input. The input pieces basically have three functions. When something starts, like when you click the mouse, hold the mouse button down and move the mouse around and let go. There's three things: start, move, and end. Likewise, when you touch the screen, move your finger and lift your finger up. You have touch start, touch move, and touch end. So this piece of code handles the MIDI control change messages, which are 7-bit. What it does is it tracks when you put your finger on the control and how you move your finger. This is basically a two-dimensional control, so in a XY mode you can have two values being changed as you move your finger around the screen. These are relative controls, so what that basically means is that it doesn't matter where you put your finger down initially. What the software does, it calculates the difference between where your finger is and the edge of the control, and where the current value of the control is relative to the extreme values the control can take. And it then scales your movement such that when you get to the edge, the control has got to its minimum maximum value. One of the components that you see on the screen is an XY pad. The XY pad is defined by the location on the screen it draws into and your finger moves around in, and the two controls that are attached to the X and the Y dimensions. So one of the things I've done here is I started to add some visual effects to the controls to make the display a little bit more interesting. So not only is this a sound synthesizer, it's also a video synthesizer in a simple way. This is an XY control, and it implements the XY pad on the screen. When you define an XY control, you define the shape, which in this case is a rectangle square, that you define where it is on the screen, by specifying the left, top, right and bottom values of the screen coordinates. And for the XY control, you can specify two parameters. These can usually be the CC7 or the CC14 objects. The grid control is an array of objects, usually n by m, and in this project it's mainly used to implement the strings which you strum as part of the guitar. So each node in the grid control has its own object, which can be whatever you need it to be. So what the control does basically is when you place your finger somewhere in the grid control, it works out which cell or square, or what you want to call them, your finger is on. When it entered you touched it or you moved into it, as you move around inside it, and when you leave it. And then it sends that information to any object that you've attached to that square or that cell. And this is how the strings are implemented using a grid control which is 1 by 6. Now in the end I made it 1 by 8. I don't use the top and bottom cells. This is just for various reasons. Part of it because the top and bottom of the screens are covered by the plastic shield so that the notification area doesn't get turned on. There are many ways to get the software onto your device. The simplest is just download it from my website. You can also set up your own web server and copy the HTML file to that and then download it from your website. The advantage of doing your own website is that you can then edit your copy and make your own changes. Some phones, if you have SD card, you can download the software onto your PC, and then by using the USB interface to your phone or tablet or whatever, you can copy the file onto your SD card. And from the web browser on your phone, using a file ://SD card type URL, you can actually access the file from your SD card and display it from there. So again, you can then edit that copy and make your own changes. Because one thing I really want people to do is actually to try and mod my mod.